Lesson 3. Anthelmintic Herbs, also known as Anti-Parasitic. What is anthelmintic? Synonyms: vermifuge and anti-parasitic. Anthelmintic or herbs, which will destroy or expel worms, are parasites from the digestive system. Anthelmintic herbs work primarily against roundworms, tapeworms, flukes, pinworms, ascariasis, hookworms, whipworms. How common are gastrointestinal parasites? It is estimated that around 80% of the world population is infected with some sort of gastrointestinal parasite. This includes adults and children. Using the 2023 world population of 7.888 billion people, that means roughly 6,300,000 million people are infected, which means you're more likely to have intestinal parasites than not. Symptoms? What are some of the symptoms of gastrointestinal parasites? Digestive issues, chronic fatigue or exhaustion, skin disease and issues, muscular or joint pain, anemia, lack of satisfaction after meals, itchiness, bruxism, insomnia, bloating, poor immune system. How do you get parasites? There are several common ways you might come into contact with parasites without your knowledge. Some of them include contact with contaminated food, water, soil, blood, or feces, not washing your hands before eating or drinking, unwashed produce, poor hygiene, bug bites. How do chemical antiparasitic medications work? Before we talk about how anthelmintic herbs work, I would like to discuss how chemical antiparasites work and why it might be more effective to turn to anthelmintic herbs. As always, I recommend you do your own research. This is not going to be true for every chemical antiparasitic herb on the market, but it is an overview of how several of them do work. Many chemically formulated antiparasitic medications work in the body as byproducts of metabolism, produce free radicals, which overload the parasites, eventually killing them. However, we know through our research that free radicals and cell oxidation is a leading cause of several diseases. It is also important to note that these chemical antiparasitic medication can produce toxin overload in the human body, as well as parasite resistance over time. So how do anthelmintic herbs work? This is where a lot of science comes into place, so buckle up. It is not as simple as to say the anthelmintic herbs kill parasites. Here we will break down the different constituents in these anthelmintic herbs and how they work against parasites. Remember, from our previous studies, that all plants have several constituents. These constituents are responsible for the plant's medicinal qualities, not the plant itself, but rather the parts that make up that plant. Constituent: a component or part of something. The constituents responsible for anthelmintic actions are considered secondary metabolites. For thousands of years, people have known that plants can be used medicinally. However, it wasn't until recently did we discover that the secondary metabolites in plants are the constituents which are primarily responsible for a plant's medicinal qualities. In the next several slides, we will discuss the specific secondary metabolites of anthelmintic herbs, which are responsible for their antiparasitic properties, as well as how those secondary metabolites work. Secondary metabolites are small molecules, organic compounds that are produced by plants. However, they aren't directly involved in their development, normal growth, and reproduction. Instead, they mediate certain functions that increase their survival and reproductive ability. Terpenes. Terpenes are the combination of different isoprene units. They show anthelmintic activity by causing intestinal damage to parasite and inhibiting egg hatching. Geraniol. The essential oil is produced by geraniums, where it gets its name: roses, lemongrass, citrus, fruit, like lemons and grapefruits, coriander, and berries, all contain this constituent. Citral. Citral occurs naturally in many plants, such as lemongrass, lemon, myrtle, lemon, verbena, citronella, and lemon and orange trees. Glycosides. The glycoside cardenolide has potent activity against different gastrointestinal parasites. It works by causing a disturbance of the sodium and potassium iodine transportation, resulting in death. Plants containing cardenolide include milkweed, foxglove, laurel and lambgill, oleander, azalea, rhododendron, and avocado. Saponins. Saponins exhibit their anthelmintic activity by inhibiting acetylcholinesterase, causing worm paralysis and then death. Acetylcholinesterase is an enzyme which immediately breaks down acetylcholine into acetic acid and choline. Momorticin. Plants containing momorticin are bitter melon and bitter gourd. Momorticin can be found in the leaves, stems, shoots, fruits, and seeds of these plants. Cunguicin N. Plants containing cunguicin N include bitter melon, bitter gourd, diac, onion, and pink jasmine. Oleanolic acid. Plants containing oleanolic acid include olive, seaweed, big, apples, and cranberries. Beta-sitosterol. Plants containing beta-sitosterol include peanuts, rice, saw, palmetto, rye, grass pollen, pygeum, and stinging nettles. Flavonoids. Flavonoids show anthelmintic activity by blocking the phosphorylation reaction, which inhibits energy production in the parasite, resulting in death. Quercetin. Plants containing quercetin include dill, onion, fennel leaves, oregano, grapes, and blueberries. Genistein. Plants containing genistein include alfalfa, caraway, sunflower, and clover sprouts and seeds. Apigenin. Plants containing apigenin include chamomile, parsley, and basil. Tannins. Tannins exhibit anthelmintic activity in two ways. They can interfere with nutrient absorption of worms from the host cell, or, when they are consumed by the larvae, tannins combine to the intestinal mucosa and cause autolysis. Catechin. Plants containing catechin include tea, apples, persimmons, cacaos, grapes, and berries. Epigallocatechin gallate. Plants containing epigallocatechin gallate include green tea, black tea, oolong, tea, cranberries, kiwi, blackberry, and peaches. Alkaloids. Alkaloids exhibit anthelmintic activity by targeting acetylcholine receptors and suppressing glucose uptake. Parasites die due to starvation. Dicentrin. Plants containing dicentrin include cinnamon, camphor, laurel, bay laurel, and avocado. Sanguinarine. Plants containing sanguinarine include bloodroot, Mexican prickly poppy, swallow root, and the 5-seeded plume poppy. Non-protein amino acids. Non-protein amino acids exhibit anthelmintic activity by damaging the worms. This affects the central nervous system of the parasitic worms, leading to paralysis and then death. Mimosine. Mimosa pudica contains mimosine. N-acyl homoserine lactone. Rehmannia glutinus contains N-acyl homoserine lactone. This is not a comprehensive list of anthelmintic constituents, but an example of several. There are other herbs, which also exhibit anthelmintic activity that are not listed, such as black walnut and even garlic.